So here in this example, we're looking at a free fall example problem of a dropped object. So it says, a stone is dropped from the top of a cliff into the valley below. If the stone falls for 4 seconds, A, what is its velocity before landing? And B, how high is the cliff? All right, so this thing is being dropped and it's falling downwards for 4 seconds. So let's write down what we know to get us started here. We know that it's being dropped. It wasn't thrown or anything like that. So its original velocity is 0 meters per second. We also know that it's a freely falling object, so its acceleration is going to be negative 9.8 meters per second squared, just like any freely falling object on Earth. And we know that the time that it's falling for is 4 seconds. The question is asking us, what's its velocity before landing? So not when it hits the ground, but just before it hits the ground. So that's going to be our final velocity that we want to find. And also, how high is the cliff? Well, another way of saying how high is the cliff is how far does the stone fall, or how much does the stone change its position? So we're going to call that delta x. We could also use delta y in this case. Some people like to use y since we're talking about motion in a vertical direction rather than a horizontal direction. But either way means the same thing. So we're trying to find that as well. Okay, so if we think about our 3 kinematics equations and which one's going to be appropriate here, we can use VF equals VO plus AT in order to find the final velocity after 4 seconds. So we're going to plug in VF equals 0 plus A is negative 9.8 meters per second squared. And the time is 4 seconds. So if we calculate that out, we end up with negative 9.8 times 4 is negative 39.2 meters per second. Now, a couple of notes about this. First of all, the velocity turned out to be negative. Think about why that makes sense. It's moving in a downwards direction. It's not moving upwards, it's moving downwards. So it should have a negative velocity. And you'll notice that that velocity is almost, not quite, but almost negative 40 meters per second. Now let me think about why. Well, the acceleration due to gravity is almost negative 10 meters per second squared. So that means after 1 second, it would be going negative 10. After 2 seconds, negative 20. After 3 seconds, negative 30. After 4 seconds, negative 40. So it's not quite negative 40, but it's pretty close to that because the acceleration due to gravity is pretty close to negative 10 meters per second squared. Okay, now for the second part, we want to find the displacement. So I'm going to write out the equation. Delta y, VOT, plus 1/2 AT squared. Now in this case, it started from rest. So our VO term is 0. This is all going to cancel out. And we get delta y equals 1/2 times the acceleration, which is negative 9.8 meters per second squared, times the time, which is 4 seconds, and we're going to square that. So if we calculate that out, we end up with negative 78.4 meters. So one of the things that we see here is that the delta y actually came out to be a negative number, and that might confuse some students. Just think about it like this. The object started at the top of the cliff, and it ended up at the bottom of the cliff. So its position was decreasing, not increasing. It's moving downwards, not upwards. So that minus sign is only indicating the idea that it fell downwards 78.4 meters. So if the question is asking how high is the cliff, I could just simply say 78.4 meters. We don't want to let this negative sign kind of scare us away. Remember what it's telling us. It's telling us that the object has moved in a downwards direction. So the height of the cliff is 78.4 meters. We said that the final velocity was negative 39.2 meters per second because it's moving in a downwards direction at 39.2. And so that's a good example of just a dropped object free fall problem.